Welcome, everyone. Thank you for joining us for today's presentation titled Broaden Your Applications with Magnetic Bead Conjugation. It's my pleasure to introduce to you Tom Lyons, Custom Projects Leader, Genomics and Diagnostic Solutions, Cytiva. For a complete biography on our speaker, please visit the Biography tab at the top of your screen. Now, if any questions arise during the presentation, we encourage you to submit them in the Q&A box. Our speaker will address your questions following the end of the presentation. So please join me in welcoming Tom Lyons. I will now turn the presentation over to him. Welcome, Tom.
Hi, thank you very much for that introduction. This is a presentation on the application or the use of magnetic beads in your own applications, in your laboratories, and specifically the conjugation onto those magnetic beads. So I'll skip right ahead from the first slide and just go into a little bit on the agenda and what to expect. So initially, we wanted to cover in this presentation was the Cytiva organization a little bit, and also the site where we manufacture our magnetic beads, which is Cardiff in the UK. And being a centre of excellence for Cytiva, it's one we're very proud of. So we just wanted to highlight a bit about the team there and just sort of show off to you guys. Then, just in case we've got any people here or any scientists here who haven't heard of the use of magnetic particles, we're going to highlight a little bit about paramagnetic properties and some of the particles that we have in our portfolio. After that, we are going to look at the applications of magnetic beads, specifically around our portfolio, and what we hope you guys are doing in your laboratories and seeing how these might give you some ideas for some further experiments. Additionally, we're going to cover the conjugation of our magnetic particles and a little bit of focus on some do's and don'ts, as well as some ideas for conjugation. And finally, we were going to cover the custom services team, customized solutions team, which I'm part of. And we were going to talk about, I'm going to talk about, how this team based in Cardiff, where we manufacture the beads, can help you further your applications and get you that one step closer to being able to use paramagnetic beads for your desired technique. So a little introduction slide, and we'll just go into the Cardiff site. So the Maynard Centre, which, as I said, is based in Cardiff in the UK, has been manufacturing biopharma particle or biopharma materials for the sector for the past 40 years. It supplies to a global customer base with over 2,500 customers in the research and diagnostic market. Each year, there are 90,000 sales of orders which are shipped to customers each year. And as I say, they're across the globe. And on site in Cardiff, there's a team of over 200 people who are manufacturing over 1,500 products for you guys to purchase. So it's quite a big site and it's quite a busy site. The team which I'm part of is the Genomics and Diagnostics team. Is the Genomics and Diagnostics business, and we're the customized team who are based within that group. There's 7 scientists in our team who are all dedicated to the custom projects. We work from university startups all the way through to large biopharma corporations, and we approach each custom product, custom opportunity with the same dedication and the same intention of output for you guys to get a product and a custom material specific for your application. We can make projects which go from very small proof of principle scale all the way up to full scale manufacturing runs, and that, depending on what application that is, will depend on what we make. And as of this year, which has been a busy year, I think, for all of us in this sector, we've been working with more than 50 different organizations across the globe to deliver custom products. So then I wanted to run on and describe paramagnetic particles. So in here, we've got a couple of nice videos which you can find on YouTube just to have a look at how the particles look and how they handle inside a liquid, which can help people visualize things a little bit. But in principle, a paramagnetic particle is not like a magnet. It doesn't continually sit there and try and attract itself to each other. They're paramagnetic in that they only show magnetic properties when they are within a magnetic field. So if you look at the slide on the left where you see there's a mixture of a solution with our paramagnetic beads, they will sit there and be diffuse and effectively become a part of the solution. Then when you apply a magnetic field, this can be simply one of our bench magnets, which we have, or a simple button magnet that some people use. The beads are attracted to that magnet and they are attracted to themselves. So they will start to agglutinate towards each other and will all be drawn into what is described as a pellet, where the magnetic field is the strongest. What you can then do is when you have this pellet at the side of the vessel, you can remove any other liquid which you don't want, or maybe you want to keep, and the beads have removed something you don't want. And you can add another solution back in. And by releasing the magnetic field, in other words, taking the vial out of the magnetic stand, the bead will go back into solution. And that's one of the key properties of these paramagnetic particles. Part of the family of paramagnetic particles that we have are the Sera-Mag beads. And these are around 1 micron in diameter. It's a very monodispersed size for them. They're super paramagnetic, which means they have a very strong magnetic moment within a magnetic field and simply zero magnetic properties when there is no magnetic field. They have this cauliflower-like surface, which I'll describe on the next slide, just to help people visualize it, which is why they seem a little bit rough on the surface. Key points for these are they have excellent colloidal stability, so they're very good in aqueous solutions. They don't like to clump up. They disperse very well. They have almost no leaching properties of the materials they're made of, so they're very clean to use in diagnostic samples. And they're very easy to use with just simple benchtop magnets, or as I said, button magnets can be used. So here we've got a TEM of the surface of our beads, and as you can see, it looks very rough and ready. And this rough surface, this cauliflower-like surface, helps some of the capture properties which are quite unique to our beads, and helps them with the increased surface area that many people comment on how our beads perform, whether that's with a custom ligand on the surface of them or whether it's our streptavidin beads, which are part of our catalogue. The Sera-Mag product range is quite vast. We sell a large amount of them with different functionalities on them. So I just wanted to give this slide for any researchers that are here who are curious about where you can use these particles in your own applications. So we cover the areas of diagnostics, genomics, and proteomics. Diagnostics in with just our core particles of carboxyl beads, which are the sort of the core particle we have. And these can be functionalized with oligos or streptavidin, as well as we have a second family, which is the core bead with another layer of magnetite added onto them. So they will move to the magnet even faster than the standard bead. The genomics area, we cover also the oligo bead and the carboxyl bead, but also with an extra focus on the streptavidin surface. Now, whether that's streptavidin just on the bead, but a further blocking, a chemical blocking of the particles for a streptavidin blocked bead. And finally, you look at the proteomics area, where mostly it's focused on the streptavidin, neutravidin binding, but we also have some bulk protein AG affinity beads as well. Additionally to the Sera-Mag family, there is the Sera-Mag family of particles, and we have two in our catalogue as it stands, a 700 nanometer and a 400 nanometer size particle. So these are our smallest particles that we have in the catalogue. They are part of a silica shell with magnetite inside the core of the particles. They have a very narrow size distribution, so they're all very similar in size, and they move exceedingly fast to a magnet. So they probably are the most rapid of the magnetic particles, or the paramagnetic particles, that we have part of the portfolio. And additionally, there is another paramagnetic product. This is the Mag Sepharose particles, and these are based on an agarose particle with a core of magnetite or paramagnetic material in the middle of the beads. These range of a size from 37 to 100 micrometer, so there's still quite a narrow size distribution, but specifically for the bulk purification of samples based on the agarose Sepharose particle sort of family of purifications. And a little bit more on how the Mag Sepharose beads, the Sera-Mag beads, and the Sera-Mag beads, those silica particles, which I talked about on here. So as you can see, there's many different coatings for both the Mag Sepharose and the Sera-Mag beads. And the silica particles, we don't have any specific functionalizations of them. At the moment, it's just the silanol surface, which is effectively a hydroxyl surface on the bead. And so depending on your application, and you're welcome to talk to us about that if you have any further questions, you can see where we can help guide you as to what type of bead might be most appropriate for your application, whether that's nucleic acid purification or protein purification, as well as some of the handling sort of techniques you may want to have with those particles. So further on from this, I wanted to talk about applications for magnetic particles. To give you an idea, if you have current particles, maybe they're using 96 well plates with some kind of solid phase to bind your sample out of a solution or your analyte of interest. So I was going to go further into that in the next couple of slides. But one thing which is very useful for all of these materials is that whether it's the Sera-Mag family of beads or the Mag Sepharose, specifically, the modification of the surface of the particles is key to how they will perform in your application. So whether that needs to have an affinity label for or a complementary label for a nucleic acid binding, or maybe it's binding some kind of probe onto the surface of the particle along with the magnetic bead to detect it further downstream. These are all the many modifications which we've had experience with in the custom team, as well as within the broader portfolio, that we're happy to help with. Specifically, I wanted to talk about the binding of a molecular probe with our poly-T bead. So, as we have, part of our portfolio has the oligo DT magnetic particles, and this will bind to a poly-A molecule or oligo in your sample. What can further be done with that oligo is you can then synthetically turn that oligo into a poly-A, but then with a specific sequence at the end of the poly-A to bind to a target of interest. And so by using the oligo DT bead to bind your oligo sequence of interest using the poly A affinity, which is built into the oligo GT, or poly A tail, for want of a better word, you can then make many different detection probes within your from the same particle, but with many different oligo sequences using, as I say, that poly A affinity at the end of them. And so this is quite a common technique for binding out targets of interest in solutions, or even binding RNA within solutions as well for further downstream applications. Then another very common use of the particles is for immunoassay, be it diagnostics or immunopurification. And here you can bind a capture antibody or a biotinylated capture antibody, depending on what your how sensitive your technique is to the biotin binding. Sometimes it can have some non-specific binding associated with it. And so you either couple the capture antibody directly onto the surface of the bead, or couple it with a biotin streptavidin conjugation. So using the streptavidin beads in our portfolio to bind a biotinylated capture antibody. This is then able to, that capture antibody will then be able to have an affinity for your analyte of interest, and further downstream, using a detection antibody with some either fluorophore or some enzyme to create a signal, depending on how much of the detection antibody has been bound on the surface of the beads. And we just wanted to highlight that particular sort of antibody affinity purification in the next slide after this, where we've got a little illustration of domain antibody expressed by E. coli, and then using Mag Sepharose, Protein L modified Mag Sepharose, to bind out the domain antibody from the expression of E. coli. And specifically in the illustration I just want to cover, we show very high binding capacity and also significant reductions in endotoxicity or endotoxins from the E. coli expression. So a little bit of a description of what we have here, but if you look at the images in the bottom left, we've used our Mag Sepharose bound to Protein L. Then by adding the E. coli expression into a wave bag, a cell wave bag, mixing them together, we then place it onto a wave platform, which is a series of magnets, which then binds out and then pulls out the Protein L Mag Sepharose with any of the toxins which have been bound to it, with any of the DAB, the domain antibody which has been bound to it, out of the solution. And so what we found in a very short period of time, as you can see from the graph on the right-hand side, within a few minutes, we've bound 90% of the domain antibody out of the solution. And we're able to then wash the whole solution with an elution buffer, a very simple one of citrate. And we've done some further investigations to show that the endotoxin endotoxicity has been reduced by a number of logs, and the EHCP reduction as well by a number of logs. So just to highlight the use of beads to capture a material of interest and to remove any contaminants you may find in your assays or expressions. So this would be a bulk purification example. So with what we have from there are a couple of examples of using magnetic beads for specific applications. But obviously, there's many applications, and one thing we're quite proud of with our Sera-Mag and the Cell Mag and the Mag Sepharose technologies is they are quite broad in their capabilities once they have been modified. Examples of modifications that we have for our particles, or modifications that we can offer. We can offer a modification of the concentration. Typically, they're supplied at 1% or 5% solid content, and we can describe the solid content to anyone if they'd like some more information. The formulation or the buffer that they're supplied in, whether they would like to be conjugated to a specific enzyme or antibody or oligo or custom ligand. We are happy to discuss and investigate custom particles for your specific applications, be those modifications of the size of the particles or some other function. We have used our particles for freeze drying or lyophilization of them, and whether that be with a custom function on them or whether that be just the standard core particle. Additionally, as I said, the Cardiff site is a large site and a centre of excellence that we have within Cytiva. And so modifications of the pack sizes or number of materials or number of products you'd like to receive per delivery is also something which we look into. So when we talk about customization, not simply the modification of the particle for a like say a specific antibody, we also look into optimizing that particle for your workflow. Typically, the beads that we find ourselves modifying are the Sera-Mag beads. Those are produced in Cardiff. Those are also produced in Cardiff. And when we modify them from two of their particular functional moieties, whether that be the carboxyl modified beads or whether that be from the amine blocked magnetic beads. Specifically, the carboxyl modified beads we will use for capturing nucleic acids just purely onto the surface, or whether that's modifying them to bind on, say, an oligo DT functionality or some other oligo functionality. And they can also be used for conjugating to proteins or other molecules of interest which have an available primary amine group on the surface. We also offer that in a high-speed version as well. So, like I said earlier, we load on a second layer of magnetite in order to allow a particle to be drawn to a magnet that much quicker. Additionally to the carboxyl modified particles, we have a further amine blocked particle, amine blocked specifically. So this now has a chemical blocking functionality on the surface of the bead. This isn't a protein blocking. And the primary surface moiety on the surface of the bead is the amine group. Similar conjugation strategies can be used. Typically, carboxyl amine conjugations are used quite readily throughout this sector. But also, it will change the surface charge of the bead as well. So you don't quite get the same binding of nucleic acids to the surface of the beads as you can with the carboxyl beads for affinity purification or DNA purification. And then I just wanted to have a little talk about, if you guys are working with our particles, just a few common challenges to make when you are using Sera-Mag particles, or typically any paramagnetic particles. Our beads are supplied in a 0.05% sodium azide preservative. If you're doing conjugations yourselves, this will interfere with your conjugations, or maybe it also interfere with your application. So we recommend washing the beads 3 times or more in your buffer of choice, be that conjugation buffer or storage buffer. And when I mean by washing, effectively it's a drawing down of the bead onto a magnet, removing the supernatant, allowing the beads to reconstitute into your buffer of choice and repeating that 3 times. It takes a few minutes, but can really help with some troubleshooting further downstream. Additionally, a large number of antibodies, which we'll buy from common suppliers, are supplied in a high glycerol concentration buffer for their stability in frozen conditions, or to enable them not to freeze. When doing conjugations for or covalent conjugations with our carboxyl beads, that will need to be removed. So whether that needs to be removed by a dialysis or some kind of buffer exchange technique, as the glycerol will interfere with your conjugation methods. What we do find for the Sera-Mag beads specifically, they're very soluble in waters and in many aqueous solutions, but we do find that they can stick to the side of some plasticware. Not that none of the plasticware that we use in-house in Cytiva, and that's one of the learnings that we have inside the Cardiff Centre, and we're happy to share whatever knowledge we have with yourselves. But we do recommend, if you are doing your own conjugations and you intend to store them in an aqueous buffer at the end, just typically add a small amount of surfactant to those buffers, which can really help stabilize the solution, but also encourage it not to stick to the surface of any plasticware you may be using. Additionally, it's worth highlighting the Sera-Mag beads are very stable in a wide range of pH of buffers. So you can go from very low to very high pHs with the same beads, and there's no further modification that you need to look out for or risk of the particles suffering throughout that. Do be aware that if you have bound a protein onto the surface of these particles, that large changes in pH can be detrimental to the protein. So you need to understand your application as well there. So we've got the last section here. I've talked a little bit about the portfolio of where we make the particles, a little bit about some applications for our particles, and then further modifications of them that you may want to consider for your own application. Specifically in Cardiff is the customized solutions team, which again is what I'm part of. And we offer a series of capabilities around the genomics and diagnostics portfolio, whether that be stabilizing of your biological material or your sample, or even your, say, master mix for lyostable, whether that's to scale up your application into a kit or into or for further use downstream as your business grows. So we can do formulations inside the manufacturing facility. Whether you would like specific conjugations of the particles, whether that's a specific oligo or protein, as I've described earlier on in this presentation. We also offer dispensing and custom modifications of plates within our portfolio. And finally, the manufacturing and kitting of your either product or kit for your downstream application. So whether that means that you particularly need certain plasticwares in there, or certain dispense volumes, or even certain documentation and branding on your products as well. These are all things that we handle within the Cardiff manufacturing site. Probably good to highlight with the title of this slide for your custom magnetic particles and how they can help you. We run through a number of steps to help you realize your custom conjugation. This does start with a number of questions about what you're intending to do, and typically we have a technical call with your technical lead or yourselves for you to have a chance to describe what you would like from the custom work. And then we also very openly describe what we're capable of and what we can deliver to yourselves. So in that early discussion can take a week or so, and then we'll go through a period of planning how we're going to manufacture it in the Cardiff site. We come back to yourselves to describe what we have planned, and then move into a proof of principle phase where we'll make a small amount of the material we've agreed upon in the planning and early discussions, and then return it to yourselves for testing, or even share with you the data which has been generated during that proof of principle work. It's quite common for the proof of principle to be multi-stepped, as maybe it's an iterative process between our capabilities and your realization of your product. But ultimately, we intend for that to lead to a final product specification. And then with yourselves and with us, we will lock down the product specification and engage with the manufacturing teams in Cardiff, specifically on how to transfer that product into manufacture, setting that up within our electronic resource management systems, as well as utilizing the full scale of manufacturing within Cardiff. This phase is typically called our validation and verification phase. And so we'll go through a number of challenges to your design, to our methods for making that design, as well as setting up, say, artwork, specific bottles and labels, specifications for raw materials. So that can take a number of weeks to get through, but by the time that that process is completed, we will be in the position to manufacture your first batches of custom products. And so that first batch will be manufactured. Again, if it's part of the validation strategy, you'll be involved with that, and we'll be involved with this custom team, as well as the quality and the manufacturing teams on site in Cardiff. But ultimately, it ends up with a place where you will have your product code to order your custom product again and again, as and when you want, as if it was a normal product off of the Cytiva website. Things which we're quite proud of in Cardiff is we're always open to audits and site visits. And in these challenging times as well, we're open to virtual site visits and audits as well. So please talk to us if you have any questions and queries. We're happy to dig into them. We're proud of our ISO 9001 accreditation and our quality management system as well, and we're happy to run through that with yourselves. And also, just finally, in case it wasn't entirely clear, this process that we have for making your custom conjugation, it's very much a collaboration between the two groups. So we agree what's going to be made, and we share with you what is happening at each step of the process, so that you can be involved and get the product which you want at the end of the day. So just to give a quick summary of where we have been through this slide. Thank you very much for your time and for listening in. So Cytiva has 3 distinct magnetic bead technologies: the Mag Sepharose, the Sera-Mag, and the Sera-Mag particles. They are all supported by the custom solutions team or custom services team in Cardiff in the UK. So please ask any questions. We are happy to work with yourselves on what is possible from magnetic particles and your application. And it's very common that with the simplicity of using the magnetic properties of these particles and how common and how capable they are to bind different functions and ligands onto the surface of them, we're confident that you can improve your laboratory workflow to help you get more data from your samples or from more samples over time. So yeah, just to highlight that we can streamline your workflow, we can improve your sample preparation with regards to how quick you can process your samples. You'll get higher purity as it's easier to remove contaminants from your solutions, and we can reduce the number of steps you have in your protocols, and indeed speeding up your time at the bench to get you more data more rapidly. So thank you very much for your time. Thank you for being part of this presentation, and I look forward to taking any questions. Thank you.
Tom, thank you for that outstanding presentation. We will now move into the live Q&A portion of our presentation. As a reminder to our audience, please submit your questions via the Q&A box. Okay, Tom, we've got quite a few questions already coming in. Let's start with this question. Are there limits to the scale possible for the custom conjugations?
Thank you for that. It's interesting. When we discuss the custom opportunities for these conjugations, we find a number of them align with our current manufacturing processes, and we're quite open with any of our discussions about what the scale is possible. So typically, the request is for a few milliliters, tens of milliliters. And then obviously there's a forecast and there's a demand if this is going to become a final product or something which is going to be expanded to other groups. So we'll typically go from the tens of milliliters with an eye to scaling it up to a couple of liters of conjugation. And that all lines up with what we currently do in Cardiff. And we have a number of discussions with the manufacturing teams, with the research and development teams to see how appropriate your custom conjugation would be for sort of that end goal to get you to the scales you need to get to. And then we'll discuss inside the project with yourselves what experiments, validations may be required to get us to that scale of conjugation with the right quality and the right kind of price for you guys. So yeah, thank you for that.
Great, and thank you. And while we're talking about custom conjugations, are the custom conjugations appropriate for use within a regulated sector?
Yeah, thank you again. Yeah, it's a good one. I think what the manufacturing site in Cardiff, which is where I'm based, which is where our team is based, where we make the Sera-Mag beads, is an ISO 9001 manufacturing facility. But the quality systems which are in place, we find are appropriate for a great many of other regulatory requirements. So what we actually ask to do was sort of the discussions with the customers, with yourselves, is to review our manufacturing processes, our quality requirements, to see how appropriate they are for your regulated area you're working in, or moving into, or you are already working within. And that typically actually covers a site visit, or at the moment, a virtual site visit. So we've done a couple of them over the last number of months as well. So we're quite open to having discussions about what we do, how we do it, and whether that's appropriate for your product going forward.
Great. And let's just keep the ball rolling on custom conjugations. How long does it how long does it typically take for a custom conjugation to be completed?
Thanks. So obviously, no, maybe this isn't obvious. We are a small team, so this is what we are in our custom team, but we are supported by a large manufacturing group and a research and development group. So what we typically find is when we get the raw materials on site, when we've confirmed what the manufacturing process is, if there's any outstanding questions, sometimes we've received, and maybe I can see other questions in there, so sometimes we've received a different paramagnetic particle, so there's some sort of exploration and experiments to look at the handling of that material. But I'd say once we have everything nailed down, we normally have the conjugate made within 2 weeks and shipping back to you for testing within that amount of time. So we'll share tracking details and so on.
Sure.
Thank you.
Sure, and thank you. Can you help me with guidance on how to conjugate my in-house developed protein?
Yeah, so obviously there's lots of considerations for a protein and sort of what's its stability, what its application, and so on. What I probably would point you towards is there's quite a good breakdown called MagBeads 101 on the Cytiva website. So you can Google it, or we can email it to you after this discussion. But that has a good breakdown of techniques and methods. But also what you'll actually find is if you get in touch with us, give us a bit of a description about what you can do, whether there needs to be NDAs in place or all those bits. And we'll discuss with you things we would do in-house. And I've got to say, quite a lot of those discussions we've had over the years have actually ended up us attempting the conjugation for you, just so you can have an idea of what the performance might be. That's quite a collaborative approach. And again, we try and be as open as we can with regards to what we can share. But also I think, certainly from my experience of working within Cytiva, within this group, I think we have a good idea of some of the burdens to entry for customers such as yourselves. So we try not to make that a financial one. We try and get to the technical challenges as soon as we can. So I'll just say, talk to your local Cytiva rep. There'll be a modality specialist who will talk to me directly, and we'll discuss your problem in technical detail, and we'll probably end up having a technical call to sort of see what the options are. So there's the website, and there's contact us directly, and you can have a chat with us on a conference call or something. Thank you.
Great, Tom. Thanks for that information. There are several questions that came in regarding that, so you've really covered quite a few questions, so thank you. Looks like we have time for just a couple more. Let's try to squeeze maybe two in. Do you only conjugate with Sera-Mag family particles? This is a two-parter. And are you open to conjugating our in-house made paramagnetic particles?
Yeah, thank you. I kind of alluded to it earlier. It has happened a couple of times where there is a specific particle developed by yourselves, or you have one which you would like to, which is more appropriate for your application. We are open to that. I would say some of the challenges with conjugation of these magnetic particles is they can be quite sticky. They may not be homogeneous or monodispersed. So, I mean, I think those are some of the real key positives about the Sera-Mag particles, that they're not sticky, they are monodispersed. But we would be open to getting your particles, whether that was the particle you guys would like to source and send it to us. We can talk about what concentration they need to be in and what functionality and buffers they are stored in, or whether there's one from a catalog you'd like us to source for part of the conjugation or whatever. So we're open to most things with regards to that. But again, always good to look at the Sera-Mag particles. they're quite good for this sort of application.
Sure. Thanks, Tom. And we have time for one more question, and I'm going to go with this one. It's come in twice. Can you ship custom conjugations to the Asia Pacific region?
Yeah, thank you. So the shipping is kind of a two-part answer. So for the custom conjugation specifically, that's with me and my team, we will drop ship. So this will be DHL Express. We will consult with our custom support team and regulatory teams to confirm how we can ship, whether we need to get licenses, etc., etc. There'll be brokers at either end. This is quite common in shipping to Asia. So it can be quite a manual process, but yes, we do it. We do it regularly. It happens also very regularly with the lyostable side of the business as well. So we're very possible to do that. I would also just sort of like close that one off is with the custom conjugations, when that does become a final product, like a product number you would buy from Cytiva, that will have all of the regulatory and the shipping terms all built into the setup of that product. So that will go through a slightly different logistics channel, through the main Cytiva logistics channel, and be distributed through worldwide hubs, which would include Asia as well. So that one, would be, there may be some more discussion up front, but when you receive the material, it will be like ordering anything from the Cytiva website.
Great. Thanks, Tom. And I think that might prompt some more questions. And I just want to remind our audience that, you know, the questions that we're not able to answer today and any questions that come in during the on-demand period. So, you know, to our audience, if you want to come back and watch this on demand, you can submit questions and Tom will be able to answer them via email. So, Tom, thank you so much for your time today. I want to thank our audience for their outstanding questions. Tom, do you have any final comments for our audience?
No, thank you very much for listening. I think it's a really broad subject. We tried to sort of pitch it as a really broad overview of magnetic beads and applications. So if there are any specific questions, let us know. And you may find that in some of the booths we've got as well for sort of nucleic acid isolation or something like that, or even just come and visit us in the custom and designing booth that we've got open as well. So yeah, hopefully speak to you later.
Yes, and I'll piggyback on that. We do have the booths available and their booth reps. There are booth reps in the booths right now that you can have one-on-one chats, video chats, and with a live person. So feel free to visit our booths in the exhibit hall. Tom, thank you again for your time today. I want to tell our audience that this presentation will be available on demand for 12 months. So please remember to share this with your colleagues who might be interested in today's topic. And don't miss out on our other presentations on the agenda. The agenda tab in the auditorium will provide a full listing. So thanks again, Tom. Thank you. Thank you to our audience. Everyone stay safe and have a great day. Bye-bye.